Okay, so we have Cn log n minus Cn plus n. I'm just still laughing that Brian is saying that Brian is correct. I'm sorry. Okay. So we do agree that Cn log n, yes. So Cn log n minus Cn plus of n, we get that. And then we have Cn log n minus C minus 1 n, right? So we get the n out of those things and we have C minus 1. So do we all agree that Cn log n minus of something basically means Cn log n would dominate this entire equation? Type in yes or no. Do you understand this? And what is the condition that this would dominate? The only case that this would dominate is when this is positive, right? If this is negative, then we are adding something to it. If this is positive, then this we are subtracting something from it, right? So Cn log n would dominate if and only if C minus 1 times n is positive, right? So for all n greater than 0, because we always assume that n is greater than 0, if C is greater than equals to 1, then this equation holds that T of n is less than or equal to Cn log n. Does everyone agree with this?
Why is it important that C minus 1 times n is positive, negative?
Exactly. So that is a very good question. So what happens if C minus 1 times n is negative? In that case, the negative negative cancels out and we have a addition, right?
Right.
And then we cannot say that it is big O of Cn log n because it is plus something. It will, as Aman says, it will go above the upper bound, right? If we add something to it. We can't basically compare these two equations, Cn log n and Cn. So I'll copy this.
So like then and in addition to this n log n, dependence on
Yes.
n comes on.
Exactly. So we have this particular equation. Exactly, you are correct. So we have this particular equation, but if this part is negative, then that means we have this plus of this thing, right? Because minus of this thing would result in a plus of this thing, right? So if this is the case, then we are adding something and we cannot say that it is big O of n log n anymore, because we have this added function of n. Does that make sense? For the student who...
We're trying to show that T of n is smaller than n log n, Cn log n, right?
Yes, we are trying to show that T of n is less than n log n. But if we add something to this particular equation, we cannot be sure anymore because we have this function of n.
Right.
Right? Okay. So
one quick question. So like, and if like C is plus, and that the C minus 1, that term is subtracting, even in that case, can we say that oh, okay, yeah.
Okay,
So
let me come back to
yes.
your question. Before that, who was asking the question about the plus thing? Could you name your name so that I can actually address you? Okay, so let's. So do you agree that this is n log n? Yes or no? Is this equation n log n? We go of n log n. Yes or no? Yes, Brian, I mean that. I have one yes, one no. Come on.
just quickly. So we are saying that n log n is the upper bound, which does not necessarily perfectly the upper bound. It can be a little more than the upper bound.
It can be upper. So what does the upper bound mean? The upper bound means that whatever time your algorithm takes, your upper bound will always be larger than that. Can we say that for this particular equation statement here?
Yeah. Because
No.
we are no for the one that's negative, we are like for the first line. For that we can say yeah.
Yes, for the first line, yes.
For
but
the third
cannot,
one, yeah. No. For the third one, no, because
we can't. And see, the first one and the third one are the same, unless we have. I mean, yes, you're correct. But we can't say that this is n log n unless we have some c that is greater than 1 or n is greater than 0, right? And if we had, so the question was, what if c minus 1 times n was less than 0? If it was less than 0, then we could have assumed that this is negative, right? Obviously. And if it is negative, exactly as you said, for the third one, we cannot say that it is n log n. For the first one, yes, but not for the third one. Yes, Brian, we are going to infinity all the time. We are never considering n equals to 10 because who cares? Yes.
What I was saying was it might be clearer if we went over if we compared the limits, then it'd be like really clear.
Okay, so I know that it would be clearer with the limits, but let's just consider this particular thing. Forget about the limits for now. Let's say that n times c minus 1, this particular equation was positive, right? If this particular equation, let's say that this particular equation was positive. If this was positive, do you agree that T of n is equal to big O of n log n? And I want answers from all of you, yes or no. Both are okay. And whoever asked me this question, I want an answer from you as well. I want 42 answers now because there are 42 students. Right? Does anyone, okay, don't type in yes anymore. Does anyone not understand why it's n log n? Tell me I don't understand and I'll explain it to you. This is not an exam. This is not a quiz. You can tell me if you don't understand. Just tell me, I don't understand. Perfect. So let's say that c minus 1 times n is positive, right? Let's consider that. So when I subtract something positive from my number n log n, it is always going to be low, right? Wise? If I subtract something positive from my number, it is going to be lower. So can I say that it is the upper bound is always n log n times some constant? Because I'm subtracting something, I don't care what, but I'm subtracting something and that is going to make it lower. So that means that the upper bound is n log n. Do you agree?
Yeah.
Perfect. Now the issue becomes, what if c minus 1 times n is negative? So if it is negative, that means that c minus 1 times n is negative. That also means that now minus times minus is plus, and now I'm adding something to this particular equation. Now, if I'm adding something to Cn log n, now it has the potential to be larger, right? So yeah. Can I again say that it is n log n? Yes or no?
Yeah. Yes.
No, no, because it is not big O of n log n. Tell me why.
Come
Yes.
again with the last part, sorry. I don't think I understood you clearly.
So let's say that c minus 1 times n is a negative number, right?
Yes. Okay.
Yes, Yaswanti, it is omega, but we are talking about big O right now. So Cn log n plus of something, is it still n log n? Let's come back. Let's just review this particular thing again. Let's say, and let's ask you this question. I'll type in Q just to make sure that I understand what the answers are. Now, Control X. Is this n log n? So I want Wise to answer and I want everyone else to answer as well, but I want Wise to answer as well. Type in the answer. Is it n log n? Wise, what about you? Yaswanti is wrong, but I'll come to that. But is this n log n?
Yeah, the 2 is a constant there, so yeah.
Right? Yaswanti, do you agree that this is n log n now? Because the 2 does not matter.
Yeah, yes, yeah.
Not you, Wise. I'm talking to Yaswanti now. So I understand that you understand. Perfect. So if this is n log n, tell me why this is not n log n. Yes, Brian, we can put any constant that it will dominate and that works fine. You are correct. But tell me why this equation is not n log n. Yes, Yaswanti, you're correct. Does everyone agree with Yaswanti here? That since it depends upon n, and since we are adding this to our equation, it is not n log n anymore. Perfect. So that is the thing. We basically, since we have this n here, negative value of this thing. So if c minus 1 times n is negative, it does not work, right? N log n does not work. So our c minus 1 times n has to be positive for it to be n log n. And that is what we are trying to prove here, right? So we say that for all n greater than 0 and c greater than 1, because c greater than 1 only works because then that means that this is not negative, right? Only for those cases, c greater than equal to 1 and n greater than 0, does we have t of n equals to n log n. Somebody, cn log n equals to x, c minus 1 n equals to y, x minus 1. Yep, there you go. You're correct. That is one way to say it. Yes, exactly. So does everyone agree that yc has to be greater than 1 in this case? And n has to be greater than 0. Type in yes or no. Type in no if you don't understand. Don't type in yes, type in no if you don't understand.